Okay, let's
Hello.
see if this is any better.
Anybody hear us?
I'm seeing a little bar on the bottom. Okay, we got it, I think.
All right. So
One more time.
one more time with the intro. So I'm Josh Montgomery.
And I'm Steve Penrod.
We're here to host the weekly update from the Mycroft team to the Mycroft community. Today we're going to talk a little bit about production of the device. We're going to talk a little bit about some of the challenges we're having both on the software and the hardware side. We're going to talk about Kickstarter, and we're going to talk a little bit about some of the things we're learning about the technology. I'd like to say that we're reporting today live from Jaguar Land Rover in lovely Portland, Oregon, where for the first time since I've been here, the sun is actually shining.
Yeah, believe it or not, it's Portland.
And we'll take some questions as we go. If you'd please go ahead and put those questions in, where are we taking them?
On the Slack, on the chat associated with this, you can type in questions, and we have somebody reading through them, and we'll be answering them as we go.
And we will endeavor not to shake the table too much as we do this, so that folks don't get seasick. So let me start by walking through a little bit of what we've built here at Mycroft. This is actually one of our Mark I units. There are no feet in this unit right now. Derek has been working really hard at my behest to get molds made so that we can put on rubber feet of different colors. And so by default, we've been able to identify a commercial off-the-shelf foot that fits on these, and they look nice. But we wanted to be able to provide feet in blue and yellow and green and other colors, so that our users can deploy Mycrofts that are dressed up the way they choose to. So we did get the quote back on the molds for that this week. It looks like we're going to go ahead and pull the trigger, and we will have different colors of feet available for when people come and order the Mycroft unit. The unit itself is held together with 4 screws that come in through the feet, and then we designed it to be split in half so that users can.
Both screws up?
Yeah, I think I got all the screws out. Let's see. So that users can split it up, and oh no, it helps if you take all the screws out.
So you do have to remove the feet if you want to get into this. We intend this to be something, those of you who are hackerish, crack it open, look at it, avoid the warranty, but be careful with it.
So the screws are specialty screws for working inside of plastics. I think we selected a pretty nice ABS plastic base, and we selected a pretty nice color. This is actually the raw color of the plastic. The ones that we're providing are a little glossier, a little whiter than this. You can see on the side of the device that there's an insert that has the open software symbol on one side, and on the other side we have the open hardware symbol. So you can take the device, crack it in half. On top, we have the rotary encoder and the speaker. The speaker is actually a fairly high quality 12-watt speaker with 8 ohms resistance. These are both plugged into the main board, so I'm going to go ahead and attempt to unplug them without breaking the wire connectors. So that's the rotary encoder, and that's the speaker. Now, one of the things and one of the challenges that we've had as a company is to get the sound quality of this to be similar to what you've come to expect from other wireless speakers. And in order to do that, the volume of the enclosure is important, and I think we did a fairly good job with that. But something that we learned over time was that if you put holes around the speaker that allow air in, it actually deadens the sound quality. So you can see that on the side of the device here, the holes in the speaker grill are wider than the speaker. We did do that for a reason. The reason was to allow cool air to enter through the bottom of the enclosure here to go through the enclosure and then to cool the device by exiting the top. After doing some heat tests, we realized that that was overkill. And so in the final iteration of the plastics, all of these holes have been filled in with plastic. And although they still appear on the outside as divots within the enclosure, they'll no longer let air out, which will improve the sound quality. So yeah, here's our rotary encoder. It has a really nice feel to it, nice and clicky, nice and solid. Derek did a really good job with the shape of the knob and the overall design of this piece of the enclosure. And then the speakers are actually, they sound fairly good. So we've got that. On the back of the device, you can see that although on the Kickstarter we promised that we would provide a single USB port and an Ethernet port, which was the original design, we've actually been able to incorporate a lot more I/O and a lot more ports by changing the orientation of the Raspberry Pi inside the enclosure. So we've got the two RCA ports in the top. We've got the 12-volt port, and then we've got 40 pins of power and I/O on the back of the device. We're feeding 12 volts, 5 volts, and 3.3 volts out on those pins so that people can use it to power all kinds of stuff. And in the case of the 12-volt, you can actually draw quite a bit of current through those pins to do robotics projects and other things. We've also exposed all 4 USB ports from the Raspberry Pi. One of the things that's happened over the course of this development that's really been fantastic is we originally designed this to run on the Raspberry Pi 2, and the Raspberry Pi 3 has been released, and what that means is that there's Wi-Fi and Bluetooth built into the actual board. So in the original device, we actually had to use one of the USB ports for a Wi-Fi dongle. In the production device that we'll be shipping, they actually have all 4 USB ports available. There's the 100 megabit Ethernet port. Just like any other Raspberry Pi, that 100 megabit port is limited by the processing power on the sock on the Pi, but it does register as 100 full duplex. And then we've added an HDMI port to all of the units. Officially, this is a debug port. Unofficially, we would expect the community is going to be able to do some really interesting things surrounding the open video, whether it's playing YouTube videos directly onto the screen or running up the Kodi framework in order to allow streaming of other video. We have a set screw here that holds the backplate to what's effectively the sound card, and the whole thing is fairly sturdy. It slides into slots in the top and the bottom. It's fairly easy to assemble. These ports in the side, the ones that have the open hardware and the open software symbols on them, right here. The reason that we made these round on the front, but then you can see that they're square on the sides. The reason for that is that they slide into a slot in the side compartment of the device, and although these are here as fillers, you as a user could actually put a square plate in that slot and add another plate in that slot that would have screw holes in it, and use this to mount the entire Mycroft unit on a gimbal or mount it, I don't know, wherever you choose to mount it, on a pair of arms, but to really make the enclosure flexible so that people can use it in different ways and keep it oriented properly. So the faceplate that we're using is a simple piece of what is it?
Plastic.
Okay, it's plastic. I don't remember which plastic.
Laser cut plastic.
It's laser cut plastic with a film on the back. We have a series of holes cut in the front for the microphone, which you really can't see very well when it's assembled, but when we take it out, it's pretty clear. And that allows us to pass the displays through as well as pass sound through. Obviously, there's the rings for the eyes painted on that. So then we have the front plate of the device. The front plate has a IR sensor, which we built, but we actually aren't using for anything. That's for people to do interesting things with if they want to. We've got the 4 matrix displays. The matrix displays were kind of a problem. So one of the things we learned.
I would say that's a lesson learned.
That is a lesson learned. There are 2 8x8 matrix display standards out there. One of them is really easy to get in the United States and costs a hair more. One of them is a lot harder to get in the United States and is less expensive. And so, you know, we went with the less expensive version. They both perform the same, so it wasn't a choice of performance. But we didn't realize that the lead time on getting these in bulk and in quantity from China is 6 to 8 weeks. And because the Chinese New Year just occurred, you can add another 2 weeks on top of that. And
actually,
so
40 days that it kicked on top of our original order.
Okay, so it added 40 days, so just a little bit over 5 or 6 weeks, because we chose this type of display instead of the other type of display. And it has to do with how the anode and cathode are oriented or something. And so that was a real issue. And so one of the lessons that we've learned through this process is that you can move electronics out into the field a lot faster if you can source all of the components in bulk within the United States. And so there's this component, and then I think some of these 40-pin, or some of these, like this 40-pin 90-degree adapter right here, I think that is also, we can only source it in China. And so ordering those parts and adding them into our bulk unit actually substantially increased the total amount of time it took us to do the project. So the other thing that's on this board is 2 Neopixel rings. These are actually separate boards that are soldered on. They're soldered on through 4 through-hole pins in the back of the plate. These are RGB, and they're actually fairly bright. Actually, they're so bright that if you run them at 100% brightness, they actually overheat. And so that's one of the other things that we learned during the process when we were playing with them. We kept having these things burn out and have all kinds of problems. And we finally realized that they were random problems. That's the worst part. And it was finally when somebody on the team said, hey, you know, they're kind of behaving like flaky, like a computer system that's overheating. And then we all looked at each other and said, oh, they're overheating. And so we've stepped into the software and taken some steps to keep that from occurring.
Also discovered some interesting things during the first production runs with regards to these. The humidity they're extremely sensitive to humidity, and had to go through a procedure that was what was a 24-hour drying out period before you're able to do any sort of a mount on it. Otherwise, again, you have some random production fallout from it. And so a lesson learned there, pay attention to the data sheets. They're serious about things like that.
Yeah, the humidity ended up being a real issue. So as a result, we have a jerky making machine at the office for pulling the humidity out of the Neopixel displays. The other thing that's on here is the microphone. The microphone is located on the front plate so that we could move it away from the main board. But we're sending the signal from the microphone back to the main board, and you can actually see it passes through a little ferrite bead. What that does is it takes a lot of the interference out of the microphone. One of the mistakes we made, and we own it, it's a mistake, is that we put the microphone up front here, and then the speaker resides right above the board here, and they're all within the same physical enclosure. And it makes it extraordinarily difficult for the microphone to detect. It makes it very difficult for the microphone to do both silence detection or to detect keywords when the speaker is playing. And so that's a piece that we're taking some steps in software, looking to do cancellation of the outgoing signal from the microphone data. But then also to mute the speaker when it's time to listen to the microphone. I don't think that will ever be perfect. I think that the real solution to that problem is to have a separate chamber for the microphone from the resonating chamber of the speaker, but we can improve the performance pretty significantly over what we've got today. So the front plate has a serial connection. Is it serial? I don't think it is. Yes,
yeah, it is. Yeah,
okay,
coming out of the Arduino.
So yeah, there's a serial pin and serial data that comes in through this 7-pin connector to the board, and that runs the LED matrix up front, as well as the Neopixel rings, which are addressed from 0 to 23, and connects back to the main board. And then the microphone connects from the faceplate to the main board with this little 2-pin adapter cable. So we'll take these off, hopefully without pulling any of the pins loose. They do come out pretty smoothly, which kind of takes us onto the main board. The main board is actually a glorified sound card with some serial and I/O on it. So we've got a Arduino, an itty-bitty little Arduino, and I don't remember what, it's like a micro.
It's the Mini Pro.
Mini Pro. So we've got an Arduino Mini Pro, and I think it's an 18 mega something.
I have to look up to see exactly which chip it is.
Okay, but it's a microcontroller, an Arduino compatible microcontroller that fits into the pins on the board. So this is just a commercial off-the-shelf Arduino, and slides right into the board and communicate with the Raspberry Pi unit on the other side over the serial bus, as well as provide serial communication to the faceplate of the unit. The other thing we did is we took a lot of the I/O from the Arduino, and you can actually probably see the circuit traces as it runs up to the back of the I/O, both digital and analog, and fed it to the 40-pin connector in the back of the unit. And what that means is that you should be able to make custom Arduino sketches that can do real-time type activities, things that the Raspberry Pi I/O is not very good at. So we exposed some of the I/O from the Arduino to the backplate so that users can build custom sketches and do interesting things with the technology. The rest of this is basically a glorified sound card. I mean, we won't belabor the point. I think the only thing that makes it really interesting as opposed to other things is that we did add 2 RCA ports. It will put out 192 kilobit per second high definition audio. So you can hook Mycroft up to a stereo and it sounds really, really good, like fantastically good. We probably will take some steps in software to disable the onboard speaker when people are using that in that scenario. But it's something that our hardware partner, Steve Vincent, who runs Lucid Labs, insisted that we have really high quality sound. I think he did a great job with that. And then the only other component that is really of interest is the actual Raspberry Pi. It's a Raspberry Pi 3. You can see that it's kind of got a little bit of a high-rise 40-pin connector to get the spacing correct, as well as some nylon standoffs. Once again, those are very high tolerance parts. Like we spent a lot of time tracking down the exact right part. You can see that they're not screw in, they're clip in. On the other side, they're also clip in to make it easy to do the assembly. That's a Raspberry Pi that just snaps right in. I guess we don't have the HDMI cable actually in this unit, but if we had the little HDMI adapter, there's a little 6-inch cable that plugs in here and then screws into the 2 holes here and provides the HDMI out on the Pi. We are not providing access to the 3.5 millimeter port. In fact, the 3.5 millimeter port in the Raspberry Pi is Satan. It has, you can explain it.
Well, it's driven by software, not hardware, so they have to do interrupts to drive it. And some of you who've used Mycroft might have noticed a few issues that occur where there's some driver level problems when interacting between ALSA and pulse audio. And I believe the problem is some of those interrupts and the software that's merging pulse audio into ALSA, they're not playing well together, and occasionally you'll get up to 30 seconds where it just locks the sound system when you're using the audio on that. So fortunately, in this case, we're using a big sound card that doesn't require us to do that, and it also offloads the software. That interrupt mechanism sucks a little power off of the Pi when you're doing that. Doing it all in hardware gives you a little more processing power.
So you can see the Jaguar Land Rover stuff going on the screen behind us. The only other piece in there is a micro SD card. We'll be shipping them with 8 gigs by default, but during the purchasing process, you'll be able to upgrade those to additional capacity for users. Are we shipping 8 or 4? I apologize.
We're shipping an 8.
Okay, we're shipping an 8.
Yep.
So so that's really kind of a hardware teardown, and I hope we actually laid out some of the challenges. So really the challenge with schedule has been this guy right here has been the challenge with schedule. It's these displays and the fact that when we ordered the proof run, which we did 10 units as a proof run, it took like 8 weeks to get those in, and then an additional 4 to 6 weeks for them to actually build the proof run. And you do a proof run because you don't want to produce 1,000 units all at once with some kind of an error in them. Actually, during the proof run, we actually did find that there was an error, and actually I think this board is the one with it.
Right, that mounting point, you notice that's flush. There's a potential short circuit that occurs, and by design, we had that offset very slightly. There's a spacer that got left out during their production. This particular one functions just fine, but of the 10, I think we had 1 of the 10 units that actually displayed the short. So
yeah,
they've corrected that.
So if we had all 1,000 units produced right out of the gate, percent failure rate, 100 of them, the eyes would have failed. So that's why you do sorry, I'm trying not to bop the table. That's why you do a proof run. So we got that. We have 10 in-house actually that are actually the production versions with the production plastics, and we've been bringing those out there. We have some software work to do. Successful. I think the only other thing that I do have a question here on the board about Bluetooth. So you want to go ahead and?
Yeah, there are a couple of caveats for people who've been working with Raspberry Pis. This is a slightly different than a traditional Raspberry Pi in a couple of ways. One, we did have to disable the Bluetooth on the device because of the way we're interacting with some of the other hardware. That was a problem. So you're not going to be able to use this in Mark 1 with any sort of Bluetooth connectivity.
By default, hold on, by default.
Unless you add a Bluetooth dongle. It's different. Even though this looks like the same kind of connector that you have off of the Raspberry Pi, it is not. Some of these pins are significantly different. Like you're indicating, there's power going to pins that there is not power on a default Raspberry Pi. Don't just plug in stuff assuming you're going to have the exact same experience that you do with a normal Raspberry Pi.
And we will
be documenting.
Yeah, we will document that. And the reason for that is, well, number one, we had to grab a bunch of pins off the Pi to connect it to the Arduino. And that, by the way, is why the Bluetooth doesn't work. Is we can either have a serial connection between the Arduino and the Raspberry Pi, or we can have Bluetooth, but we couldn't have both at the same time. So we did disable the Bluetooth. We will be providing Bluetooth dongles as an option during the purchasing process. So people who want to buy the little $4 dongle can plug it into one of the USB ports. And then the pinout was selected that way specifically so that we could do both real-time I/O from the Arduino and then also Raspberry Pi I/O from the Pi, and give people maximum flexibility for how they use it. If you look, you'll see that the 40-pin connector is actually flush to the back of the device. So we are building and providing as an add-on a little breakout board that makes it easy to connect these pins to whatever project that you want to.
Cobbler style connector. Yeah,
a cobbler style connector. So now we could talk a little bit about software if you want.
Yeah, one other thing, since we're talking about sort of the hardware software interface, this Arduino, we will be providing access to the default Arduino sketch, the C++ code to build that. So you'll be able to do whatever you want with it. It is limited how much you can put on there, and by modifying it, you are going to change what's going on with the front faceplate, the default menu system and such. It's up to you. You can add things to it, make it do completely different things, whatever you want. All of that source code will be posted on GitHub at the time that we start delivering these devices for you.
And the intrinsic limitations in terms of the memory on the Arduino, like they're intrinsic to the chip.
Yeah, it's just Arduinos.
But I will not represent that we wrote the most efficient Arduino code for that thing. So that's a place where the community can probably reach in and take what is I don't know how big is that file, like 10K, 100K, something. 2K?
It's for the actual sketch itself. It's something like 14K or something.
Okay, so yeah, like 16K of memory or whatever's in there.
Yeah.
And go ahead and pack that down into 2K. You know, change it down to machine code or however the community decides to solve that problem. We obviously will provide it in a working condition. So yeah, one of the other things on the menu today, I think, was we had software challenges.
Hardware, software, Kickstarter challenges, learnings. Got a few of the learnings in there.
Okay. So in terms of software production, so from an umbrella viewpoint, which is the viewpoint I get because I'm not involved in that day to day, I'm primarily working to build partnerships with companies like Jaguar and others. I think things are going fairly well. I have a unit that I do demos on. There's clearly room for improvement, but the team seems to be making good progress, and we're just now starting to get metrics. And all you folks out there who fill out the survey, thank you so much. That really gave us a better view of kind of what the customer experience is with the Mycroft unit and with the overall technology, and we're really paying attention to the feedback. I think that we're going to be in a really good place when we start shipping these here in however many weeks. And I think that folks are going to be pretty happy with what shows up. That being said, you know, during the Kickstarter campaign, we had a stretch goal, which was to get Linux on the desktop, or get Mycroft on the desktop. You'll see over the next couple of weeks us deploying in a KDE Plasmoid that's available across the entire KDE ecosystem. There are app packages out there that folks can pull down and put Mycroft on the desktop. And then folks will be able to embed Mycroft in their own IoT devices. So we made a lot of progress on that side of things. And then some of the core skills, things like spelling and news and questions and answers and Wikipedia and other things are going very well. Some of the places where we still need to do a lot of work is surrounding if this, then that. We have a Pandora skill that works. It could definitely use some improvement. We need to get Spotify working. There's a number of software skills that need to be pushed out, and we're in a position where we have to decide: do we use what's considered a waterfall approach and just keep developing until we hit all of the skills that we ship, which could push shipping back even further than it is today, or do we ship with what we have with a great core of the technology with 12, 13, 14 of the skills that we identified and running, and then push updates over time. And after talking about that with the team and with some of our customers, we feel that the best way to handle that is to hold off and ship 3 months. No, I'm kidding. We think that the best way to handle that is to go ahead and ship as quickly as possible and then push updates as new skills are developed. One of the other things that is on our agenda for software is to make it easier for you as a user to modify the systems and contribute your own skills and help to contribute to the community. So we're going to move as fast as we can with the software and get it out the door. But Steve leads that effort, so I'm going to let him speak to what's going on.
So there has been, especially during the fall, a lot of the focus was on the hardware side of things and getting through all of these production challenges and these challenges of acquiring equipment and such. We've been over that hurdle and sitting waiting for things to deliver largely. Right now, this week, at the start of the week, I received a message from Customs. So the matrix displays that we were talking about coming from China, those have been, they're in the United States, but they've been sitting on the dock behind a fence somewhere with Customs agents looking at them. So we expect to be receiving them by the end of this week, maybe by early next week. We're really just waiting on them to give the thumbs up and to let them out. The plastics have been produced and we've got pallets shipping coming our way from there. So in general, I think we've got all the pieces ready to hand over to the manufacturer to start building these boards for us. What I outlined in my latest blog post, where we're trying to, our target is to get it out by April 15th. Some people are complaining about April 15th as a day for other reasons. That should be an achievable target still, and we are still moving toward that on the hardware side. On the software side, we've been pushing more and more into that realm, since we don't have to focus on the hardware anymore while the production runs are going on. And so we've been building out the tools and working to get the community to a point where community skills are easier to build. That's been one of the challenges right now. It's easy to build things when you get interested in something, and I don't want it to be a difficult challenge. I want it to be easy and fun to build things. So that's going to be our focus over the next handful of weeks here as we wait for all of these devices to get produced by our board house, and then we'll be distracted for a little bit longer while that's going on, and until we start our actual ship date. Got a few questions floating through here too.
All right, so how much will the Mark I cost once it's publicly released? My guess is that the price will go up slightly. The folks who backed us on Kickstarter, we want to make sure that they get the best deal possible, but it won't be ridiculous. We'd like to keep it on par with the Amazon Echo, if that kind of gives you a kind of a feel for where we're headed with it. Let's see.
Someone's asking, are you going to make some point or app for controlling the Mycroft? There are actually some interesting things you can do with Mycroft. For one thing, if you are on the device, you can have your skills interact in any way with any sort of a web service that you want to provide. So you can build custom skills to interact with equipment within your home. You can create, you could even be listening to, you can go as far as creating your own tornado instance listening on a separate port. There's a lot of different things. The fact that we've built it in Python, pretty much anything you can imagine you can do on these devices.
And we have set it up so that the initial setup of the device is done via a smartphone or a laptop. You connect to the device's SSID. Maybe we'll do a demo of that in a future video to make it easy to connect to the Wi-Fi. So yeah. So we'll look for one more question, and then I think we are out of time. Which IoT devices can I integrate? That's a good question.
Yeah.
We've got a number of skills that are under construction. I know.
Well, I know that the Philips Hue bulbs, there's a skill that's, I know it works because somebody was just talking about it. And then I've used Wink interactions through the Wink web APIs, and that's going to be very easy to make that function on Mycroft also. Honestly, again, since it is a Python environment that you can develop skills in, any IoT device, you should be able to interact with it. There's no reason that if someone hasn't built it, it shouldn't be easy to build. And that's one of the big things about the, and someone's talking about, we have a
Nest skill as well. Right. I know that people have been playing with the Belkin standard. Mm-hmm. So there's a number of things that are in development. What we're building here isn't something that we're building in-house. We're not, we don't have 100 engineers. We're not locking the code up behind closed doors and promising folks that it's going to have a lot of value someday. As a proprietary platform, really we're open, and we believe very, very strongly in the open ethos. It's why last week I talked a little bit about our core principles: fast, open, simple, strong. Open is the foundation of our community, and from our perspective, that openness is really a two-way street. Is that we're investing our careers and large sums of money and a huge amount of effort in building this open technology and publishing and making sure it's available for the broader community. And what we're hoping is that the community will turn around and reward that openness by contributing back so that other people can take advantage of their expertise and their interest, whether it's an interest in building IoT skills surrounding the token standard, or an interest in plugging a Pokemon wiki into the back of Mycroft's skill stack. And so, we are absolutely committed to working hand in hand with the community for when there is a need and we want to deploy something new, to facilitate that and to put full-time resources on it if it makes sense, and to really build a user experience that creates an AI for everyone. So I think that's all we have time for right now.
I believe so.
Yeah, the last question I have is, still planning to put Mycroft on the Linux desktop? Mycroft is on the Linux desktop. If you head over to our blog, you can see some posts about Mycroft on
KDE Plasmoid.
On the Plasmoid and Debian app packages, or Debian packages that you can pull down and install. Start playing with that. That's still very early, so the user experience could still use some significant work, but we are finally bringing the same functionality that companies have had, companies like Amazon and Apple and Google have been building into their products to the broader Linux community, and we're really excited about that. So anyway, I think that's enough for today. We really appreciate all the time and the effort. I wanted to give a shout out to AIX, who has been doing a lot of the work surrounding the Linux desktop. Thank you so much for your time. And here in the near future, it won't just be me and the talking head and Steve. We've actually asked the other employees to come and give some talks as well. So hopefully we'll be meeting some of the developers, guys like Carl and Aaron and Lusto and Mateus, the guys who are really making this possible, and maybe get some questions in for them and get to know them a little bit as well. So thank you so much.
Thanks, everyone.
Appreciate it.
Goodbye.